All right, get ready to dive deep with us today because we're taking a closer look at Tritordeum. You've been doing some research on this interesting grain, and there's something that's piqued your interest.
Yeah,
It's amazing ability to withstand drought. So how does it do it? Well, let's find out.
that's a great question, and one that scientists have been looking into for a while now. Before we get into the specifics, it's worth remembering that Tritordeum is a hybrid.
A hybrid.
Yes, it's a cross between durum wheat and wild barley.
Wild barley.
Yeah, Hordeum chilense to be precise.
So it's got this unique parentage.
Mm.
But how did scientists first realize that this hybrid was a drought superhero?
Let's take a trip back to 1989 when a landmark study was published.
1989.
Yeah. It was a pivotal moment in the world of Tritordeum research. They wanted to pit Tritordeum against some of its relatives.
Like what?
Wheat, barley, and even tritotocol.
Tritordeum.
Yes, it's another interesting hybrid.
What is it a hybrid of?
Wheat and rye.
Right. I remember hearing about it somewhere. These hybrids really showcase the ingenuity of mixing genes, don't they?
Totally. It leads to some really special outcomes. Anyway, in this study, they put these cereals through a drought stress test.
A drought stress test.
Yeah, they grew them in both well-watered and rain-fed conditions. This would mimic what happens when water becomes scarce.
So they turned up the heat and waited to see which plants thrived. What were the results? Did Tritordeum meet expectations?
Absolutely. The research revealed that Tritordeum was excellent at maintaining a more stable water balance compared to other cereals. Especially when drought stress increased, it's as if it has an internal water tank.
Interesting. So it's a pro at water conservation. Were there any other adaptations that helped it deal with drought?
Of course. The study showed that Tritordeum has a talent for growing deep roots. While the other plants struggled near the surface, Tritordeum was busy extending its roots deeper, reaching water sources the other plants couldn't.
Like having a personal well, accessing water deep underground, even when the topsoil is parched. Clever.
Precisely. But there's more to it. The study also examined how well these cereals maintain their rate of photosynthesis during drought stress. You know, photosynthesis is the way plants convert sunlight into energy.
It's how they make food.
Exactly. You'd think that under drought conditions, their ability to photosynthesize would suffer.
That makes sense. Less water, less energy.
But Tritordeum defied expectations. Even in dry conditions, it maintained a decent rate of photosynthesis. It's a resilient plant, determined to keep producing energy no matter what.
So efficient with water, deep roots, and drought doesn't hinder its food-making abilities. Tritordeum is quite impressive.
And it gets even more interesting. Fast forward to a recent study,
When was this?
published in 2024, led by Yoldi Ajalandabaso and their team. It really delves into what makes Tritordeum so drought tolerant.
Okay, I'm ready for more. What did they discover?
This study built on previous research. They compared Tritordeum not just to modern varieties of wheat and barley, but also to those known for their drought tolerance.
I mean,
Barley landraces.
wow. Barley landraces are the ultimate survivors, aren't they? They've evolved over centuries in some of the most arid places.
You got it. Yet, even against this tough competition, Tritordeum held its own.
No way. It's like facing off against an Olympic athlete and winning.
It truly is. The study found that Tritordeum isn't just about survival, it's about remaining productive under pressure. They focused on something called the harvest index. It measures how much energy from the plant goes into grain production.
So not just about staying alive, but producing food, even when times are tough. And what did this study reveal?
Even under drought conditions, Tritordeum maintained a high harvest index, meaning even when water is scarce, it prioritizes channeling energy into producing grains instead of other parts of the plant.
Wow, this is getting exciting. Tough, efficient, and focused on providing what we need most. What else did this study uncover?
Well, this is where it gets even more fascinating. Yulia Chalandabaso and their team decided to zero in on a very specific part of the Tritordeum plant. They measured photosynthesis in the ears.
The ears.
Yep. And what they found was astonishing.
Wait, the ears are photosynthesizing. I always thought that was the job of the leaves.
Absolutely. Leaves are generally the photosynthesis powerhouses, but Tritordeum has an extra trick. The ears themselves significantly contribute to the plant's resilience during drought.
Like a backup power source. That's amazing. I never realized how crucial ear photosynthesis could be. It's like a secret weapon that other cereals don't possess.
Exactly. This additional adaptation helps it stay productive even when water is limited.
It's as if this plant was made for a dry world. Makes you wonder how it evolved these remarkable abilities.
That is an excellent question, one that scientists are still working to understand fully. However, the research we've discussed gives us a good idea of what makes Tritordeum such a drought-tolerant superstar.
All right, let's recap for our listeners. Tritordium's drought resistance isn't just a single feature. It's a combination of factors. It uses water wisely, it has deep roots that access hidden water reservoirs, and now we know it even has ears that can photosynthesize. This is a cereal ready for whatever challenges nature presents.
Absolutely. And these adaptations aren't just scientific curiosities, they have real-world implications, especially considering climate change and the need for sustainable agriculture.
It sounds like Tritordium could be a crop for the future.
Mm.
But this is where things get really intriguing.
In what way?
Well, if it's this good at handling drought, why isn't it more widespread? There must be a downside, right? What could those be? We'll delve into that after a short break. So we've uncovered some amazing drought-busting powers of Tritordium. It's a water-wise cereal, got deep roots, and even its ears contribute to photosynthesis. But like any superhero, I'm guessing there's a weakness lurking somewhere, right?
You're spot on to be thinking that way. Remember the 1989 study we mentioned earlier? The one where Tritordium went head-to-head against other cereals?
The drought stress test. Tritordium totally dominated.
It did. But the researchers stumbled upon something quite interesting. Under ideal, well-watered conditions, wheat actually outperformed Tritordium in terms of yield.
So that's the trade-off. When water is plentiful, wheat takes the lead. It's a bit like the tortoise and the hare, isn't it? Tritordium being the slow and steady tortoise, perfectly suited for the long game in a dry world, and wheat being the swift hare, sprinting ahead when resources are readily available.
That's a fantastic analogy. It really highlights the delicate balance between different plant traits. However, it's not quite as simple as declaring wheat the winner in ideal conditions. Remember the 2024 study by Yol Diachelandabaso and their team?
The one that showed Tritordium maintains a high harvest index even under stress.
Exactly.
So even when water is scarce, it prioritizes grain production.
Precisely. And this brings us to another potential trade-off. If a plant dedicates most of its energy to producing grain, it might have less to spare for other parts.
Like stems and leaves. So less overall biomass, which is what farmers often use for animal feed or other applications.
Exactly. This is where things get even more complex. A 2024 review by Papabopoulous and colleagues reminds us that Tritordium is relatively new in the world of crops.
Oh, right. It hasn't undergone centuries of breeding and selection like wheat or barley.
Precisely.
So there's room for improvement. Hopefully, you've gained a new appreciation for this remarkable grain and its vast potential.
Perhaps even some food for thought, questions about the future of food, the choices we make as consumers, and the power of science and innovation in creating a better world.
Beautifully put. Thank you for joining us on this captivating journey. We'll see you next time on The Deep Dive, where we'll explore yet another fascinating corner of the world of knowledge.